In this video, I'm just going to give you a brief overview of differentiation just to help you with the concept when you're doing non-constant acceleration. You will be doing differentiation in Unit 1, but if you do tend to be out of step with the teaching, then this is just a little bit of a catch-up just to let you know how to differentiate. So if we imagine that we have a function y is equal to ax to the n, where a and n are constants, i.e. just numbers, then the differential of this would be dy, change in y, over change in x, is equal to a n x to the n minus 1. So what we do is we technically bring the old power down and we multiply as the coefficient, if there is one, and we reduce the power by 1. So for example, if I was using just a generic function, y equals x squared plus 2x plus 3, then what we do is when we differentiate, we get dy by dx is equal to 2x, power comes down, reduce power by 1, plus 2. And the reason why that goes to 2 is obviously if you reduce a power of 1 by 1, it goes to x to the 0. So actually, if I write that in there, I'll simplify it in a minute. That gives me x to the 0. And then 3 just disappears. When we differentiate a number, it just goes. And I'll explain that in a second. So we're left with this function here. Well, just to write it a little bit simpler, we get dy by dx is 2x plus 2. If I was looking at this in terms of a non-constant acceleration equation, so if I talk about displacement as a function of time, so x is 2t cubed plus 2t squared plus 3, and I want to find velocity. We know that velocity is equal to the differential of displacement, dx by dt. So again, following the rules, I would bring the old power down. So 2t cubed would become 3 times 2, which is 6t, reduce the power by 1 squared. Then the squared power would come down, multiplied by the 2, that would give me 4t. And then the 3, obviously, when you differentiate the 3, that would just disappear. And that's how we differentiate.